Okay, this is derivatives of inverse trig functions. The first example is the function y equals inverse cosine x inside of a radical. So the first thing you need to do is change the radical to an exponent. And from here you can use the chain rule, which would move this exponent to the front and then subtract 1 from your exponent. And you have 1/2 cosine, inverse cosine x to the negative 1/2. And then times the derivative of the inside, which is, this is from the 6 inverse trig functions. And the inverse function for cosine is negative 1 over radical 1 minus x squared. And then you simplify this to 1 from here, that's the 1, and then negative 1 from over here, over 2 times the radical of inverse cosine x times the radical 1 minus x squared. So then you're going to simplify to y prime equals negative 1 over 2 radical inverse cosine x times radical 1 minus x squared. And that's the first example. For the second example, we need to find the derivative of inverse tangent 3x. And what you need to do is plug in the function from the inverse trig functions. This is the one for tangent. It's negative 1 over 1 plus x squared, and then the derivative of 3x, which is 3. And then you're going to plug in 3x into this x and simplify it. You're going to get negative 1 over 1 plus 9x squared times 3. So over here, f prime of x equals negative 1 over 1 plus 9x squared times 3. And you're going to get f prime of x equals negative 3 over 1 plus 9x. For the last example, we're going to find the derivative of radical x squared minus 1 cosecant, inverse cosecant x. And the first thing you need to do is change the radical to a fraction exponent. And you're going to get x squared minus 1 to the 1/2 power. And then inverse cosecant x. And then f prime of x. You're going to do the product rule for this, so you need to do x squared minus 1 to the 1/2, which is copy derivative of the second, plus derivative of the first, times copy. And then you're going to do x squared minus 1 to the 1/2, and you're going to plug in the inverse trig function of this, which is 1 over the absolute value of x times the radical x squared minus 1 plus 1/2 x squared minus 1 to the negative 1/2 2x cosecant, inverse cosecant x. And to simplify this, you're going to get two fractions, x squared minus 1 to the 1/2 over the absolute value of x times the radical x squared minus 1 plus 1x squared minus 1 to the negative 1/2 times 2x times cosecant, inverse cosecant x over 2. And the answer is going to be f prime of x equals radical x squared minus 1, because you change this fractional exponent back into a radical, and then the denominator is absolute value of x times the radical x squared minus 1 plus 2x inverse cosecant x over 2 times radical x squared minus 1. And you can simplify this again by canceling these two x's